Hi, I've had this Tormach for since last year, and I've been using it for some optical fixtures and custom optical components. But I've been wanting to go through the Titans of CNC um, series, the fundamentals one. So I started with the 1M. Was finally able to get that done. Um, the Titans tutorial on this is for a different machine, and some of the tools are quite different, and so I decided to go through each one of the tools, go through the feed, speed, some of the settings that I used. They got it to work. Now, it's not perfect, but it will work, and I think the big one for me was the getting the threads to work on the 1032 holes, and so I go through that, and yeah, it was a lot of fun. Really liking it, and so hope this is useful. Let's get to it. 1032 screw on there. Nice and easy. Now that we've completed the part, I'm just going to walk through some of the feed, speeds, and actual settings that I went through to get this part completed. Here we have the first setup, which is just starting with the top. In all of these, I've taken it pretty conservatively, just because limited experience with these tools, and so wanted to first get to a point where I knew it would work. So let's just kind of walk through the settings and all these. For this 1.5 inch face mill, we're at 4,000 RPM, 35 inches per minute. Let's see. Just taking off the top based on my raw stock. Okay, so multiple depths. I did do 0.0125, probably way overkill in terms of how many, maximum step down, but I haven't pushed this tool too hard yet. And so this is kind of just where I know it'll work. I did run into situations where I was pushing it too hard on the aluminum, but I know this works, so just went with that to get this process, or this cutting process, done. Linking, I don't find myself using a lot, but okay, so that's tool 1, facing. So then it's the adaptive clearing steps. Initially, I'd gone all the way down to the bottom, the 0.75 of the 1M, in a single adaptive clearing step. I think it probably could have managed that with this 3/8 tool. But essentially what I did is I just took it in and broke it up into 3 steps. So the spindle speed on this 3/8 tool is 4,000, cutting feed rate 8.5. Again, probably a lot slower than it needs to be, but I know this will work And so that's what I went with. Let's see. Heights. Yeah, so for this first step, I went 0.26. I, for the most part, went into quarter-inch increments all the way down to 0.75. And let's see, I did leave a little bit of stock here on this one. I think it was for, so yeah, you may need to, finish the remaining of do like a finishing pass to get rid of that, the 10,000s. This one, I do, okay. I think that's it on that one. Mostly it was the spindle speed and cutting feed rate that was giving me issues. I think I was going a little too fast previously, and it was just getting stuck on the aluminum. Let's see, on the linking, these parameters seem to work for me. So if you're not sure which ones to choose, these worked on my 440. So yeah, I think that's it for the adaptive clearing. Again, the only difference with the three different steps is that my clearance top height is always model top, and the bottom height is just kind of incrementally down all the way to 0.75. All right, so then the next tool. I did do a finishing pass here. So that's essentially adaptive clearing or 2D contour. Same spindle speed and cutting feed rate, pretty much, but just to kind of clear out the remainder of the 10,000s that I left with the adaptive clearing. All right, let's see. Did a 2D pocket on the inner, again, to eliminate that stock I left. Same spindle speed, cutting feed rate. The next is the chamfer tool. This kind of just gives you the chamfer on the outer top edges, the outline, the inner outline, and then this bottom portion here. It was a 4,000 spindle speed again, with a 20 inch per minute cutting feed rate. On this one, the chamfers is not something. It's something I need to address a little further in terms just for myself, trying to figure out tip offset, for example, and whether the chamfer is designed in versus something like down here where it's a straight line that I didn't design it in, and I come in and I chamfer it anyway. So something I need to play around with, but essentially the takeaway here is I used 4,000 spindle speed and a 20 inch per minute feed rate. Let's see. Okay, so then essentially followed the steps on the 1M tutorial by CNC Titans. This seemed to have been helpful. Also, it kind of is part of the part, right? It needs a little bit of chamfer on the bolt holes. So that was pretty straightforward. Let's see here. I used 4,000 spindle speed and 8 inch per minute feed rate on those. I think I may have used a slightly different drill bit size for the pilot holes, or not pilot holes, the actual drilling of the holes. So let's see. Yeah, I used the Kennametal 0.1610 This is the actual measurement that I measured with my calipers. That's what I put in my tool library. But that's the drill bit that I used is in the description of the video. And I think it might actually be a little bit smaller than the drill bit used in the CNC Titans tutorial. In any case, this worked for me. And with this one, I kind of just wanted to be conservative. I didn't want to run into any issues with the minimum. I think the minimum on this was 0.32 inches. And so this one, I did in 2 different steps. So let's see here. Yeah, 0.38. And then I think I went down to 0.58. So probably a lot more than I needed to, but just wanted to make sure I didn't run into any issues. And then the drill cycle is deep drilling, full retract. I think actually it would have been more helpful to do well, anyway, this worked. This one wasn't so critical. I think most of the drilling operations are pretty straightforward. 4,000 RPM and plunge feed rate of 16 inches per minute. Okay, and then this last one took me a while. In the 1M tutorial, Titan talks about using a form thread mill or form tap. And, I tried that in 3 different types of taps. It just wasn't working. The tap kept getting stuck, or really it just kept getting stuck. I broke a few, just wasn't working. I ended up going with a single profile thread mill, which did end up working. I don't think I'm using this 100% correctly. In fact, I'm pretty sure I'm not. But I did get it to work. The trick here that I was able to do, okay, so, heights down to about 100,000s beyond what the minimum was. Again, probably overkill, but okay, so I did, number of step overs was 5. Step over at 2000s. So probably, again, super conservative. The thing that I ended up, okay, so first I started with stock to leave. So I'd run into issues where I just wasn't getting it. So initially I started with stock to leave at 4,000s. I ran the process. I started milling out the threads, but it just wasn't, the bolt I was using to test it just wasn't catching. So eventually, I worked this down 1,000th at a time, which, so 1,000 at a time. Finally, I left 0 stock to leave. The threads still weren't really catching. So then I went to where is it? Well, let's see. Okay, so yeah, it is here. So thread really was this I was playing with. It's the pitch diameter offset. So it just essentially kind of dictates how much it's digging into the material. So I think this is where I'm not doing this exactly right. What I did was I took the cutting in the tool library. I set the cutting diameter to what the manufacturer specs indicate for this tool, which is wider than what I actually measured. If I'd put in what I'd measured, maybe I wouldn't have to do this diameter offset, but just decided on one approach, and that was, okay, go with what's the cutting diameter supposed to be, and then offset it until you're digging enough into the material that you're able to catch onto the thread. So pitch diameter offset of 30 thousandths got me there. Remember to make sure that the thread pitch is 31, I think it's 3125 for 1032 thread. And that did it for me. I was able to get the part done. The last step, of course, is to just do a second setup, flip the part around, and then for this second setup, I just did a face operation and took off the remaining of the raw stock on the flip side. I think if I were to do this again, I'd probably chamfer the bottom as well, just from a feel standpoint when I pick up the part. Yeah, so that's a summary of the tools. Love any comments you have on how I could have done that better, or if you have any questions on maybe something I didn't cover on the specific tools I used, please let me know. All right, well, I hope that was helpful. The part's not perfect, but from a dimension standpoint, the length, width, and height are within the plus or minus 5 thousandths that the 1M calls for. So I'm going to go through hopefully all 10 parts, see how we do. And if you need any help with gas sensor design, gas spectroscopy, manufacturing, or data acquisition, data collection, please visit our site, redwoodlabs.tech. That's .tech. And book a free phone call with me. I can walk you through some sensor architecture, troubleshoot, come up with solutions for your ideas or your problems. And thanks a lot. Hope that was helpful.